Good morning, everybody, and it's my pleasure to welcome Sharad today. Sharad is a multidisciplinary citizen scientist, researcher with a strong focus on applied mycology. He has been leading research on developing novel biomaterials using fungi as the chief scientist at Dharaksha Ecosolutions Private Limited. He has also been maintaining the largest private type culture bank with over 120 species of fungi of both native and exotic origins. Sharad is also an avid urban farmer and in his free time likes to grow his own food. You can get in touch with him on his Instagram handle, Charles Pakwasi. I also followed you yesterday. So welcome,
Okay.
Sharad, and I'm very excited
Hi
to hear
everyone.
your talk.
Hi everyone. First of all, thank you to MycoAsia, Bele sir, for giving me the platform, and for you all to for giving me your time. To a lot of you might be postdocs, MTechs, PhD candidates. I am a self-taught mycologist. Most of my learning about culturing fungi and working with fungi has been from books and internet. I'm absolutely humbled that so many of you have come today to listen to me talk about mycomaterials. Title for the workshop today is Mycomaterials 101 with Sharad, which is me in association with MycoAsia, which is one of the leading journals in Asia and globally if you want to publish mycological research, academic research on fungi. Who am I and what's today's agenda? I'm just an infinitely curious, ordinary guy who's spent the past 7 years observing and working with fungi in different capacity. I've been collecting samples from the wild uh, and culturing them on agar and then preserving them on slants to use. I've collected so far over 120 species, both from foreign origin and indigenous fungi. You can contact me on Instagram, Charles Bukowski, and I'll be leaving my email and phone number later on towards the end of the presentation. So the agenda for today is we're going to talk about the types of mycomaterials, the state of industry globally and locally, how to grow your own mycomaterials, and further discussions on future possibilities. And then we'll have a question and answer round where if you have any doubts or if you want any clarification, you can ask me then. How I plan to, so the objective for today's workshop is to give you all an understanding of what is possible in material science using mycelium, which is fungi, and how you can start microfabrication at your home using low-tech methods. Hopefully, building a community of radical material scientists dedicated to exploring the microverse and all its possibilities. Hopefully, by the end of today's workshop, as for some of you, your interest would have peaked in fungi and biofabrication, and hopefully you'll give it a try, and that might lead to and more exploration and building a community together. Rules are simple. I will try to cover most of the presentation in under 90 minutes and have a question and answer round at the end. So the final 30 minutes are reserved for that. If you have any questions, just hold on to them. Maybe you can raise your hand and maybe Gunjan can take them on and we can all have them at the end of the session. Before I begin, I hope my audio is clear. Uh, if
Yes, it
it's not,
is.
yes, great. Okay. So what is mycomaterial? Like myco word comes from the Greek word mycos, which meant mushroom. So basically any material that is derived from fungi or using fungi is a mycomaterial too. And examples of such materials are you could have paper, you could have dyes, you could have foam, you could have leather-like materials, and possibilities are really endless because mycology by itself is a very young science. Until 1969, which is the year we sent a man to the moon, we were considering fungi as part of the plant kingdom. It's only in 1969 that mycology, fungi separated, fungi got its own family, and mycological research actually really started, to take shape. And so it's a young science. We don't have enough people working on it. We need more people because I believe fungi are a great, resource waiting to be explored. And we should work with fungi, an organism that we've overlooked for the large part of human history. So, and so the possibilities of what we can make with fungi are limitless. This is an example of a myco paper. Myco paper is made using a similar process as you would do for wood or pulp-based papers, except that in pulp-based paper, large content of the paper is cellulose and lignocellulistic in nature. Whereas when we are making paper from mycelium or mushroom, it is very chitin heavy. Chitinase is different from cellulose, which plants have. Mushroom fungi have chitinase in their cell wall instead of cellulose, and that gives a very interesting texture to the paper. And personality, in my opinion, to paper. So there are a few companies that make arts and craft papers out of mushrooms, out of mycelium substrate. And these are just a few examples. You could also dye them using fungal dyes, like you can see on the image on the right. These are dyed using different fungi, and so yeah, you could get different shapes, form, thickness, texture, and color from paper made out of mycelium. There's also mycofoam, which is what my company makes and we're currently working on. These are some of the examples of the product that we're developing. These could be used as packaging material, but could also have other applications. It's basically a replacement material to styrofoam. So anywhere where styrofoam can be used, we can replace styrofoam by using mycofoam. We're going to talk about how you can get started with trying to make mycofoam at home and then see what all can be made from it later. There's also myco leather, which is piquing the interest of a lot of designers and brands as they move to sustainability. Leather industry, as we all know, is a heavy polluter, uses a lot of heavy metals in the processing, dyes, and these can leach onto the water bodies nearby and create pollution. In fact, fashion industry is one of the biggest polluter globally. Myco leather can be made sustainably. We can grow sheets, long form sheets, and then these sheets can be processed in a similar way to leather to get different texture, color, etc. So this is another application, another material that is piquing the interest globally. And maybe later we can someday have a workshop on how to make myco leather at home as well. So what's happening in the industry? Like, is it all hype? Is our Mycomaterials really, taking on? We don't see much packaging in the market made out of Mycomaterials. So these are just a few companies. These are all unicorns at this point in time, which means they have more than $1 billion revenue. They are all well funded. As you can see, most of these companies are based out of US and Europe, where the research landscape is much better. So these are basically the industry leaders globally, Ecovative especially, Mycotech as well. These guys are global leaders in mycomaterial technologies. Uh, Similarly, there's Mogu, there's Mushroom Company, there's these are all unicorns, and there are globally over 60 plus unicorns, which means 60 plus companies with more than $1 billion valuation, which are either already working in biomaterial, mycomaterials, or are foraging into it. And these are all big companies. But what's happening? This is all globally, but what's happening in India? So in India, my company Dharaksha Ecosolutions, the company I work for, was featured in the top 30 tech startups in India. We are well funded. We're funded by big name investors like Rain Matters, by Zerodha, Momentum Capital, Let's Venture Fund. So we're really the industry leaders in this technology, microfabrication technology, where we've already hit the market with several clients who are using our products. We're currently collaborating with several others to basically design packaging for them, to help them switch to more sustainable packaging and reduce their carbon footprint. So we are really the industry leaders in India. I'm not going to be humble about it. And so, yeah, what are we doing? Why? I mean, how is Dharaksh different from the other global giants who are working with uh, mycomaterials and biomaterials? So our target is not just to make mycomaterials, but it is also to use waste streams which currently create pollution. So, for instance, the rice stubble in North India is one of the major sources of pollution. In fact, right now, I believe the AQI in Delhi is over 400. And it's been like that for about 2 weeks, and for the whole month of November onwards, when the rice crop is harvested, the farmers are not left with much of a choice but to burn the stubble. That creates a lot of pollution, and combine that with the environmental conditions like wind speed and etc., it creates a gas chamber like conditions in Delhi. So what we've done is what you can see here in the images, we've taken over, stocked over 150 ton of stubble, and this equates to about 2,800 kgs of particulate matter or soot, which would have polluted Delhi's air. We've removed that by capturing all that carbon and making a useful material out of it. At the same time, we're replacing plastic, so we're killing two birds with one stone. And this is the model that we wish to go forward with, create more sustainable solutions, which are not just focused on making material out of microorganisms, but to also utilize waste streams which are nearby. This again requires a lot of R&D again, because for anybody who's grown mushrooms, they would know that different mushrooms like different substrates. This is because of the choice of nutrient profile that different fungi like. So while some may grow well on sawdust, some may grow better on wheat straw, others would like to grow on manure. So, when you're trying to work with local waste streams, it's important to understand what the nutrient profile is going to be in the raw material mix that I'm going to grow on, but also the choice of fungi, which preferably should be a native fungi. So, but can I make this at home? So this pot was grown at our facility in Dharaksha, where, as you can see, the plants are healthy, the pot's pretty stable, and towards the end of the presentation, I might show you some more examples of Mycomaterials and their practical applications, which are not just limited to packaging. So, like you can see, you can make pots, lampshades, uh, bowls. It really is up. I mean, you can let your imagination go nuts. Okay, so what do you need to get started? At home, I imagine some of you want to experiment with mycomaterials, see if you can grow your own material, which is fun. I mean, for the most part of human history, we've been manufacturing materials, but this is the age of biotech, and it, manufacturing materials is a old school way. We grow materials. So what do you need to grow such a material at your home? First of all, you need mycelium. Mycelium is essentially the fungi. What we call mushroom is essentially fungi, and fungi is essentially a subterranean organism that dwells beneath the top layer of the soil, and it grows in the form of filamentous hyphae. So mycelium is, you need mycelium that's going to do our biofabrication job for us. Then you need a substrate. Substrate is anything that the fungi will grow on. In our case, depending on the kind of material we're trying to go, we choose our substrate. So, say for foam-like materials, we are going to use agricultural waste streams and combine them in different ratios to get something that the fungi will like to consume. And as it consumes the substrate, it binds the substrate with it. You need gloves, you need a mask, you need 70% ethanol. I think after Corona, we all have these things at our ready disposal in our home. You need tissue paper, you need any kind of mold, the kind of shape you want the final material to take. So you need that mold. You need a shrink wrap, a sprayer, a mixing pan, and a measuring cup. Another question is, which fungi should I go for? I have mycelium, but what kind of mycelium? So I say you experiment, but popular choices would be from Pleurotus species, Ganoderma species, Fomes species, Tramates. These are mostly polypores. Ganoderma, Fomes, Tramates, these are all polypores. They grow on lignocellulistic substrate. So, for instance, Pleurotus is a saprophytic fungi. It decomposes wood in nature. Ganoderma is a parasitic fungi that attacks trees, and over the course of a decade kills the wood, and then it also displays saprobic properties, so it also breaks down the wood. Fomes is another fungi that you go for. Tramity is again a polypore. So polypores is a good place to start if you're trying to fabricate lignocellulistic substrate. Otherwise, you could go for other fungi as well. I really encourage you to experiment. Go out in the world, find fungi, see if you can culture them. If not, then most of these species you could procure from a vendor. Like there are several vendors like Novedo, Fungipedia. There's Shroomery. You can buy a ready to grow kit, and you can use the mycelium on the substrate to biofabricate your material. So another thing that you want to consider is what kind of material are you trying to make. So this is a electron microscopic image of Ganoderma lucidum, Pleurotus austratus, on two different substrate choices, substrate types, and this is the pattern of their growth as observed under an electron microscope in 5 days, 10 days, and 20 days. As you can see that the width and the size of the hypha and the complexity of network is different for all the fungi. So uh, and you can see that Austeritas has wider hyphae, while Ganoderma has narrower hyphae, but the network is much more dense. So it really depends that what kind of material are you trying to make. Materials made out of oysters would be weaker in nature because the nature of the mycelial network that is binding the lignocellulistic substrate together. So that's one consideration. You would also want to consider other things. This is another image. This is a AFM image of different fungal hyphae. You can see how they vary in length and uh, size and form factor. So depending on how you want your material to be, you can choose your fungi on basis this information. So you can go online, research on different species. There are several papers that can describe the morphology under a microscope, growth conditions, the ideal substrate ratio. So depending on what kind of material you want, you can choose a fungi. But if you're a beginner, I say go with oyster, because oysters are one, very, very resistant to contamination. I think they're the most widespread fungi. So no matter where you are, you're very likely to find oyster. And they're also very forgiving to amateurs and beginners who have not got a hands-on understanding of aseptic technique and sterile methods. Uh, right. Again, so another consideration would be what kind of temperature do you have? uh, what kind of environmental conditions, including temperature, relative humidity, what is the condition where you want to grow this material. And so, say you live in a colder climate, but you're trying to use a fungi that prefers warmer temperatures, then it won't be ideal for you to select that fungi for biofabrication purposes. You'd be better off selecting a fungi that is more suitable to those growth conditions, namely what kind of light, what kind of temperature, and what relative humidity that particular fungi likes to grow. Another consideration will be what kind of mold. So there are several choices of mold, but mostly there's the plastic mold, which is your traditional plastic form factor. This is made using a technique called thermoforming. So you could go with that. The advantages of going with plastic is that where you can reuse it again and again to make several molds. And this kind of plastic can stand, if it's a polypropylene or a polypropylene mixed with polyvinyl chloride mold, then it can withstand a higher temperature that are required for the sterilization stage or the pasteurization stage. But really, you could also go with clay, which is modeling clay. You can make it out of plaster. Plaster can withstand higher temperatures, so you could technically sterilize this. Or you could go with 3D printed or aluminum or steel or any metal based mold, which can be disinfected either by heating it or by using disinfectant. So these you could ideally go for any of these. In most industrial cases, the molds that are used are made out of plastic. Since it's cheap, it can be reused, and it can also be recycled. For instance, at Dharaksha, we recycle all of our plastic. So once a mold is past its life cycle, we break it down into small granules and return it to the vendor who is our eventual supplier. So that way, no plastic exits the cycle, none of it enters the environment, and it's a circular process. But you could really go with anything, any inorganic material for your mold. It's important that it's inorganic, because any organic material, the fungi will start growing and consuming on it. So you could actually technically go for an organic material if you want the mold to eventually become the part of the material. Then you could go for something like a cardboard or something like that. So let us begin. Feel free to make this an open discussion for questions and clarifications from before proceeding from here on. If you have any questions for me, you can ask me right now. But any question that you have right now, you can ask me. After this, I will begin the step-by-step process of biofabricating at your home. So if you have any doubt about what we've discussed so far, this would be a good point to bring it up. Are we good? Should I just proceed?
I just wanted to ask how you like
Yeah.
choose. Let's say Ganoderma is there, Pleurotus is there. You said these are commonly, so we should just pick one from outside and start experimenting.
Yes.
Or some
Yes.
PDA. We need some substrate like agar or something, or
Yes. So yes, you'll need to if see, for beginners, you can just go and buy a kit which is essentially a grow your own kit, which is meant to grow mushrooms. But
right.
instead of growing mushrooms, you could break the substrate down and use it in your mold. So there are Ganoderma kits available. There are definitely there are several Pleurotus, Ostratus, grow your own kits available for very nominal value. And I think Novedo, companies like Novedo, Fungipedia, Shroomri, they all have it in their stock. So one could just order a kit, break down the substrate, put it in their mold, and follow the instructions that I'll be giving in the next part of the workshop, and they could get their material. But the other way is for, say, if you're well versed in sterile technique, or if you have an access to a lab. Most people do not have an access to a lab, so culturing a fungi from outside becomes a big problem. But if you can, then please go out in the woods and find polypores, bring them back, put them on PDA, let them grow out, make a liquid culture, transfer it to a substrate, and then get your own basically substrate mix and fungi instead of buying something from market. So for instance, like this is Fomes fomentarius. This is one of the samples that I retrieved from a forest, and I cultured the culture. I took a tissue culture from this fruiting body, and then what I can do is expand that culture onto a liquid culture, and then a lignocellulistic substrate,
This is
and
one
grow it
fruiting
out.
body.
Pardon me?
This is one fruiting body. It's a giant
Yeah,
mushroom.
so this is I kept this fruiting body. This is because this is an excellent example of gravitropism in fungi. So when the tree was upright, the fungi was growing like this. So the fungi can sense which way to drop their spores to maximize the dispersal. And then a landslide came along and the tree fell. And when the tree fell, the new growth realigned itself to again drop the spores in the most optimal direction. So I've preserved this sample as an example to show people that fungi can sense what direction they are in. But another example would be you can get samples from outside. You can go to forests, your city parks. There are several polypors growing on trees. Some polypors that I've experimented with, I haven't even been able to identify them, because I mean, just to identify them would I would
Yeah.
have to do ITS sequencing and that. But point is that experiment. I've given you a starting point. That oyster is a very good starting point for anybody who is just getting into mycology, or just getting into biofabrication.
Right. Sridhar and Gundappa has raised hand. So first Sridhar and then to Gundappa. Sridhar.
Hello, sir.
Hi.
Hello, sir. Yes, sir. Yeah, sir. Sir, you used the substrate is chips based is better, or used in the sawdust like in the powder is one? Which one is better choice, sir? That
Sir,
materials.
see again. This is it's like saying what should I use to what wood should I use to make my sofa? it
Okay, okay,
this is up to you. What kind of shape you want? Do you want smooth features? Do you want slightly rough texture? What kind of texture and final product would you like? Depending on that, you would choose the size of your substrate, the type of your substrate, and other parameters like hydration of the substrate. So there is no one size fits all this thing. So it's important to experiment. It's important to try different mixes and compare the texture, compare the quality, the strength of the material, the compactness of the material, all these things. See, this is a young science. This is very much R&D, research and development process. So there's no research out there that we can refer to and say, "Ki, oh, all right, for if you want this kind of texture, you go for this substrate and this temperature and this fungi." So it's a lot. It's a lot about experimentation. So I encourage you to go find different substrates like sawdust from different wood, different kind of agricultural waste like what soya bean hull, or any waste stream that is locally available to you, so that there's not a lot of carbon footprint in procuring that raw material. So and another approach that you could try is, say you've chosen your fungi, say you've chosen pleurotus, right? You can go online and look for the ideal carbon nitrogen ratio for pleurotus, for the optimal growth of pleurotus, right? Once you have that
okay,
carbon nitrogen ratio, what you can do is you can design a substrate mix according to that carbon nitrogen ratio. So so if say you have an idea, okay, this is the carbon nitrogen ratio, that means in my sawdust, if I'm using say oak wood, or if I'm using mango wood or XYZ wood, this is the amount of carbon which you can get. That data is easily available online, so you can get a understanding of what is the composition of that lignocellulistic waste, how much nitrogen is there, and then you can design your substrate. So it's like asking how to make paneer ki sabzi. Like, everybody makes their sabzi differently. So go ahead, experiment, see what works for you, see what doesn't, and chalk things out, cross things out. That's the way to go about it.
So I have another one question, sir.
Sure.
The PDA plates have been you grown on the culture after you transfer to the spawn like in the sorghum grains. That is the better, or you transfer to directly into the culture plate too, and that is substrate. Which one is the better
You
choice,
could
sir?
you could you could you could you could actually just take the PDA and transfer it to your substrate mix, and that will work too. Point is that when we're using substrate, the idea should be to have quicker growth, right? So then your culture, your media that you're using to inoculate should be ideally, for PDA, it will be a small wedge and it will start growing out locally and take a lot of time. That will give time for other contaminants to attack your substrate and could contaminate your entire substrate mix. So, so ideally, you can go for grain spawn, you can go for liquid culture, you can even go for solid media, which is like agar or a slant. So you could go for any of those. So, for instance, this is liquid media that I have ready with me. I could use this for inoculation right away. The advantage is that in liquid culture, you can see how the mycelium is free to go in different places, right? So if I use liquid culture instead of, say, something like solid culture, which something like a grain spawn, which is like this. This is grain spawn. This is mycelium growing on grain spawn. You can see that it's growing very locally from one place, right? But if I had used liquid culture, the mycelium could spread easily into the bag and it can colonize it quicker. So you can use agar, but I don't recommend going from agar to substrate. Ideally, you can either go the grain spawn route, or you can do the LC to substrate. Or you can also do substrate to substrate. You can prepare spawn from sawdust and mix, and then just use that to mix with more sterilized substrate.
Thank you, sir.
Yeah.
I think using substrate will be more cost effective also, and we can also be sustainable by using the waste material. So that will be better.
Right. You could ideally go either route, and it really depends on the economies, what's available, how costly is it. Is it cheaper to just make an LC? Because when you are using LC, the other thing is that you could technically sterilize an LC in a pressure cooker. If you put it in a pressure cooker and let it boil for 20 minutes, that will sterilize everything. And using a filter disc and an injection port, you can technically, without having a laminar flow hood or a sterile environment, you could inoculate fungi. So it's really up to you. Experiment, see what works.
Yeah. Rahul Saha has a question. He has raised his hand.
Yeah, Rahul.
What pH we should maintain, sir?
What?
pH.
pH. So ideally, fungi like slightly acidic environment. Most fungi, including Pleurotus, Ganoderma, that. So you can keep it anywhere around 5 to 6. Just that's fine.
Thank you, sir.
Yeah. You really don't have to maintain pH a lot when it comes to fungi, mostly because your LC is, your liquid media or your agar media is already around 5 to 6 pH, depending on what you've added to it. So most fungi will grow just fine. You don't need to worry a lot about pH, is what I'm saying.
Yamni
Yes,
has a question.
Yes, Yamini.
Yes, it's very nicely presented. So I have a little question regarding if different mushroom varieties have been used, like Pleurotus, Ganoderma. So if you have been able to find difference in the mycomaterial quality, or if there is beforehand, if there is a way to select out which one would give the better, with respect to its strength or other quality parameters.
So I think, I don't know if you missed the last part of this thing. We discussed the graphs where we saw how different hypha look differently and morphologically they're different. So because they're morphologically very different from each other, the end result of their fabrication is also very different. So in my experience, I've found Ganoderma, Trametes, Fomes, these to be slightly stronger, but they end up making the material more denser, while Pleurotus the material is not very strong, but it's usually lighter. So
Okay, so for
once
a
again,
beginner, like
if I
they
can
can pick up
just
any of the mush. Yeah.
yes, so I'll just show you that graph again, just in case missed it. Yeah, go on. Ask me your question. I'm just gonna pull up.
Does anybody else have questions? And you stop sharing your screen, so you need to share your screen again, Sharad.
Okay, one second. Yeah.
There is Prateek Patra who is asking one question, that is there any coating required in the material?
Is there any coating required in the material?
Yeah.
That really depends. I mean, that depends on you if you want. So you could paint it. Painting is certainly possible. You could, that, but that's up to you. That's optional. So to answer your question, you can see the difference in the width of the hypha, right? The width and the girth of the hypha. So in
Yes,
Ganoderma,
yes.
you can see within 20 days the network is really dense. It's really dense, but the hypha are narrower. They're comparatively narrower when compared to Pleurotus ostratus. And in both the substrate, you can see on cellulose and PDB plus cellulose, PDB cellulose and cellulose, you can see that the network is completely different. So, going back to your question that what should you use, that really depends. That this graph should tell you what you should use, right? In a combination of other considerations like what temperature can I grow it at, and what relative humidity is it easier for me to maintain. Because at home it's really difficult for people to maintain these parameters. So it's perhaps best to choose your fungi and your substrate depending on what conditions you can maintain. So yeah, okay. So if there are no further questions, I think we can begin with the walkthrough of the process.
Yes, please.
All right. So all right. So there are 5 essential steps to make your mycomaterial. Step 1 is preparing your raw material. Step 2 is sterilizing or pasteurization of growth medium or substrate. Step 3 is inoculation and molding. And step 4 is ensuring the right growth conditions. And final step is the deactivation of mycelium and drying to derive a stable material that you can then use. Sterility, first off, very important for people with non-microbiology background to understand what sterility is, because in any biofabrication process, sterility is going to be your primary consideration. So it's difficult to achieve sterility at home because your air is constantly bombarded with billions and billions of spores. Every cubic centimeter of column of air in your room has about a billion spores just floating around in the air. These can compete with your fungi, your choice of fungi, and sometimes outcompete it. And in that case, your biomaterial will not bind well or will not bind at all. So it's important to understand sterility. A good place is, of course, YouTube. You can go to YouTube, understand what aseptic method is or what sterile technique is. And once you have a better understanding, you can really begin, begin more complex operations in mycomaterial like culturing fungi, right? So, but if you're beginning, I would just say disinfect everything with rubbing alcohol. Imagine everything has corona and you gotta disinfect everything except for your mycelium to begin with, right? So use disinfecting wipes to clean your table before you begin working. Wear gloves, wear masks, make sure you wash your hands with soap all the way to your elbows. Try and cover most of your skin because your skin is basically harbors a lot of contaminations. Cover your mouth with a mask. Try not to speak when you're doing the biofabrication process. And any mold or scissors or anything else that you'll use will really have to be disinfected with sterilant like alcohol, 70% alcohol. All right. So we've already gone through the broad list of equipments, but I'll just go through it again. So a mold of your choice, you will need a foil to cover it if you don't have a lid. If you have a lid, then that's great. Wash your mold. If it's made out of plastic, aluminum, steel, anything else, wash it with soap and place it upside down so no air can fall and spores can fall into your open surface where you're going to be doing your inoculation. So you need a mixing bowl to mix your substrate and your mycelium. You need coffee grounds, that's really optional. You need some kind of woody substrate, so hemp, sawdust, fine straw, and have try and experiment, see what mix works for your fungi. So you'll need this to mix your mold. The cooking pot, high pressure cooker, this if an autoclave, if you have an access to an autoclave, that's better. If you have an access to sterilized substrate, that's really good. If not, you can really use a pressure cooker to sterilize some of the material. If not, you can go for pasteurization. If you're using oysters, pasteurization works for oyster. The pasteurization is slightly different from sterilization. In sterilization, we kill all competing microbes and only leave that leaves the media with and rid of any microbial growth. Whereas in pasteurization, we kill most of the contaminants except the contaminants which can survive or thrive at high temperature. These are called thermophiles. But in case of oyster, these thermophilic microorganisms actually promote the growth of oyster mushroom. So if you're working with oyster, pasteurization is great. It's an easy process where you just pour boiling water on your hot substrate, keep it covered for a while, and then once it's cooled down to room temperature, you can combine it with your mycelium, any spawn that you're using to kickstart the growth process.
Can I interrupt you?
Yeah, sure.
Senpon has raised her hand
All
or
right.
his hand.
All right.
Yeah.
Yeah.
Senpon. Now she's gone. All right. I don't know. The person is gone.
Okay. All right. Is the presentation still visible?
Yes.
Okay, great. So yeah, you need a cloth bag in case you're pasteurizing. Then you can fill all your straw in a cloth bag and then dip it in boiling water and leave it there. Then you can later on remove your substrate from the cloth bag and combine it with the mushroom spawns. So stove, you need a stove, water, plastic gloves, alcohol, thermometer is good to have. If you don't have, then it's okay. Just as long as you're using boiling water. Let the water boil properly before, when it starts to bubble up vigorously, then you can pour it in your substrate. Okay, so step is to mix your fibers. Now, these fibers could be, so in West, they use hemp fibers, but hemp may not be easily accessible to most people in India, in which case you can go with agricultural waste, like you can experiment with wheat straw, rice straw, soybean hull. You can experiment with combining this agri waste with sawdust waste stream that is locally available with your either woodworking guy or the furniture manufacturer. They usually have tons and tons of sawdust which they throw away. So you can use a mix of these. Again, when you're making your mix, you want to check the carbon nitrogen ratio in your substrate and see if the carbon nitrogen ratio is right for the species that you're trying to grow. Step two is that once you've mixed your substrate, it's time to first of all hydrate it and submerge it in water. So and you need to bring it to field capacity. Field capacity is essentially when the point at which a substrate cannot hold any more water. So at that point, what you want to do is you want to take some of that substrate, put it in your palm, and give it a light squeeze. If there is a stream of water flowing from your substrate, then it's likely overhydrated, and you need to let some of the water evaporate before you can use it. So the water content in your substrate should be on point and at field capacity. So check if your substrate and water is at field capacity before you before you proceed to the pasteurization or the sterilization step, right? What if you have an autoclave at this point in time? You can load this substrate mix in a bag, and you can put it in your autoclave and autoclave it for 1.5 hours at 121 C and 15 psi, and that should sterilize your substrate and make it ready for inoculation with your fungi. But if you don't have an access to autoclave, then what you can do is you can put your mix in a cooking pot in a cloth bag and let it boil for 30 minutes, and then you can take it out, pour away the excess water, and let it cool down to about room temperature, and then you can use it to inoculate it with your fungi. This is essentially pasteurization. It may not work for some species of fungi. It will work for pleurotus though, for oyster. If you remove the cloth bag, the substrate will cool down quickly, and you can get to it faster. But from at this point in time, make sure that everything you touch has been disinfected, or anything that the spawn or the substrate touches is sterilized or disinfected. So presence of mind is one of the biggest factors in getting a good success rate in biofabrication. Before you do a process, think about it in your head, live that process in your head before you actually start doing it on the field, right? So see if you've done step 1, step 2, step 3. See if everything you've done is according to the flow of the process. All right. So next steps will be done in rapid succession to avoid unnecessary risk of contamination, which means you have to be quick with the process, because we are not doing this in a sterile condition. We're doing it in our homes where billions and billions of competing spores are floating in the air. So the quicker we can do this process, the quicker we can close the access of these contaminants to our substrate. And really the key to high success rate is putting lots and lots of spawn when you're doing in a non-sterile condition, because putting a large population of our chosen fungi can sometimes help it outcompete other contaminants. So the more spawn you can add, the less your chances of failure would be. Making the mixture. So, like I said, from this point on, please disinfect everything. Your hands, please don't try to talk, cover your hair, disinfect your gloves, disinfect everything, basically, from this point on, right? So, anything you do from now on where a lid is off, basically, where we're opening a bag or where the vessel in which we've kept our substrate, we have to make sure that everything is sterilized and or pasteurized. So you want to any metal thing like a spoon to pick up the grain spawn, or forceps or anything like that, they should be first flamed, which means that they should be heated in flames for a little while, so that any microorganism on its surface gets incinerated. Okay. Uh, Now, when the substrate cool down to about 30 degrees to 35 degrees, you can begin the preparation for mixing. And if you don't have a temperature, it's fine. Just touch the bag and see and feel if it feels at room temperature, if it feels warm to you. Uh, a fair warning: if the substrate is too warm and you introduce the fungi when it's too hot, then the fungi can die, because the higher temperatures that it won't be able to survive. So just make sure that it's close to room temperature when you're transferring your fungi. So then the next step is preparing the mold. Once we've prepared our mixture, sterilized it, we'll keep it in our vessel. Either it's a pressure cooker, or if you're doing pasteurization, then it'll be a large tub. So we'll keep a cover on it and we'll start preparing our mold on the side. So for the mold, if you're using a plastic mold, you want to wash it with soap, and immediately taking out our soap, you need to spray it with 70% alcohol and keep it face down, so that the interface with the air is limited. You also need to get a foil. Usually your aluminum foil is already disinfected from the process of the manufacturing of aluminum foil, where the aluminum foil is introduced to high temperature and then pounded. So this process kills a lot of microorganisms on its surface, so it should be fine. But leave the first few layers of your aluminum roll, and you can use the rest either directly, or you can use 70% alcohol to spray the aluminum foil. This aluminum foil will be used to line your this thing and cover your mold. So you alternately, to cover your mold, you can use shrink wrap as well, which gives you visibility into how the substrate is growing. But you can use foil also if you don't wish to see what's happening inside your mold. So you have everything you need. You have your sterilized substrate on your side, and you've now disinfected your mold, and it's ready to go. So what you want to do is you want to open your sterilized substrate, immediately open the spawn bag or whatever spawn you're using, mix it, and then use this mix to stuff your mold on one side from the top. And you can stuff it to your desired density. If you want your mold to be really dense and strong, then you put a lot of material into it. If you want it to be light and spongy, then you do not compact it a lot when you're introducing it in your mold. So once you've placed enough substrate in your mixing bowl, take it and add so if you're going to make 1 kg of substrate, the rule of thumb is to keep it at 10%. So you're going to use 10% mushroom spawn. So for 1 kg of substrate, you're going to use about 100 grams of grain spawn or 100 mLs of liquid media. Mix everything well, make sure that it's well distributed, the spawn is well distributed, and the mixture is looking homogeneous, so that the growth from all areas is uniform. But do not risk over shaking, because shaking actually damages the mycelium, the hypha of the fungi, which is fine because they grow back again. But if you shake it too aggressively, then it may destroy all the hypha, or none of the hypha to begin its growth again, and then you're going to just have substrate with no growth. So now that you've mixed your substrate, your spawn, it's time to put it in your mold. Take your disinfected mold, quickly spray it with 70% ethanol, let the ethanol dry out, and immediately take your mixture of substrate and spawn and start putting it in your mold. Once you're done to the desired level, you want to cover your mold. So if it has a lid, then you should sterilize the lid, which is, if you can't sterilize it, then disinfect it, wash it with soap, and then spray it with 70% ethanol. Cover it up, and that should do. So this ensures that no dust or no other contaminant, unwanted contaminant, enter the mold while our fungi is growing. And it also prevents the evaporation of water. So fungi require the right amount of water, and if we leave it open, the substrate may dry out, and in which case our mycelium will not be able to cover the entire form factor, and in that case we won't have a very sturdy biomaterial in the end. So if too much water is allowed to escape, the substrate will dry out. So what you can do is you can either use shrink wrap, make tiny holes for air exchange, and then you can cover those holes with either a masking tape or a micropore tape, which you can find easily in any dispensary. So you can use that for air exchange. You need a little bit of air exchange because fungi, like us humans, mammals, they consume oxygen and release CO2. So if you don't make your mold breathable, then the CO2 concentration inside the mold will build up, and we can get suffocated with higher concentration of CO2 in the atmosphere, so can fungi, and that affects their growth. It can either slow it down, or it can completely stall it.
Naresh has raised a hand.
So this is an example
Sharad.
of, yes.
Naresh has a raised hand. Yes, Naresh,
Yeah,
please
sure.
ask your question. And then I also have a question.
Sure.
Naresh. Okay, I think it. Anyway, my question is, do you use incubator? Because you're talking about oxygen, carbon dioxide. So there are certain carbon dioxide
So
incubators
see,
also available.
for industrial production, and of course we use all these fancy equipments. We need to have that to optimize the growth cycle. But it's not a must-have. I mean, if you have an incubator, sure, go ahead, knock yourself out, use it. But if you don't, then just understand the considerations and try to keep the parameters within it.
Okay. But if we do it at home, like what is the ambient environment? Should we put it in a dark place, warm area?
No. So all fungi work well with light. That's not an issue. In fact, some light is encouraged.
Okay.
So that's fine. What you can do is, like, if you're growing oysters, for a place like Bangalore, it's all year round you can grow this material. But for, say, somewhere like Delhi, maybe in summers, unless you have a air conditioning and room that you can keep it running, then it becomes difficult to do the biofabrication process with pleurotus during summers when it's 48, 43,
Yeah.
44 degrees. So have that consideration. If you can maintain the environmental conditions, then great. If not, then work with the fungi that grow in those conditions. There's always, for every environment condition, I've found a fungi. I mean, from like
Yeah, that's true.
4 fungi fruiting at 4 degrees, 3 degrees, to fungi fruiting at like 40 degree, like Calocybe indica. You can go for Calocybe indica in warmer conditions where it's 40 degrees. Then you choose a fungi that grows at 40 degree instead of having a AC on and using the energy to just cool down the space. Yeah. So
Indu has raised hand. Indu, do you have any question for Sharad?
I have a question.
yes, Sindhu.
Yeah, so
Yeah.
basically, you have just told that mycelium needs air exchange. So for that, we are putting some holes on the cover or the mold caps and all. And again, you're
Yes.
saying that we need to cover it with the tape. So what is
Yes.
that exactly? How can
Right.
air
So if you
exchange
leave the hole as is, then any spore in the atmosphere can enter it, right? So say this liquid culture jar, there is a filter here, right? What this filter is essentially doing is, this is a 0.22 micron filter. So 0.22 micron is small enough for any spore to be filtered out. So this is essentially doing that job. What you can do is, you don't need to buy one of these syringe filters, which are membrane filters. What you can do is just take 2 layers of doctor tape and put it on top of the hole that you're making. So that will reduce the chances of spores coming in, but the gases can exchange because the gas is atomic and molecular size. So that can still go in and out of the mold. But because contaminants are bigger than that size, they can't enter.
Okay, thank you.
Yeah. Yes, Deepak.
Hello, Sharad. Yeah, this was a very interesting workshop. And what I would like to know is what becomes the differentiator, process-wise for making, let's say, myco foam and myco leather or the
Right. So
paper. Yeah.
good question. So essentially, see, all these processes are essentially growing the fungi either through a material or on top of a material, or in some cases sandwiched between two materials. So today we are only discussing the process of myco foam. Later on, maybe we can someday have a workshop on myco leather and myco other kind of pure mycelium foams. Like, these are not pure mycelium foams. These are actually biocomposites. So this is lignocellulistic as well as mycelial material, but there could be pure mycelium, and it really is just the difference in the process of doing it. Most of it is essentially the same thing, which is find a fungi, grow a fungi, transfer a fungi to a media, and depending on what morphology you want, you choose that media and conditions. So that's the only consideration is what kind of process you'll do.
Okay. Yeah, I understood. Yeah, thank you, Sharad.
Yeah. So for instance, like leather, most of the leather is grown on either a very thin layer of substrate or grown on liquid media, and then harvested, and then you then it's processed. So what we are making is the least processed material. It's purely just lignocellulosidtic waste and mycelium. But for a lot of this thing, you need to do post processing also. These post processing steps depend on the end usage, right? So if you're using the material as something at home, like a bowl or a flower pot or an ashtray, then you really don't need to post process as much. But say if you're doing this as a business, or you want to make it more shelf stable, then it needs to go through multiple processing to make it more resistant to contamination for the period of storage of the product, make it more pest resistant. So all these things, then you need to have more post processing steps, and most of these steps are really IPs and uh, trade secrets, really. So that's something that you experiment and work out. So but yeah, but materials do go through post processing. It's not just harvesting. And in case of leathers, we basically do the same process, except for the post processing also includes a plasticization step. So in which we essentially use smaller plasticizer molecules that can go in between these larger molecules and provide more flexibility to the material, and just improve the qualities in general. So that's the only difference. I mean, more or less, it's the same process. If you want to get a foam, it's a different, slightly tweaked process. If you want leather, it's slightly tweaked, and if you want micro composite, slightly tweaked. But essentially, the bare bone of the process is the same for any fabrication, and not just fungal. Even bacterial fabrication follows the same process: sterilization, substrate, your chosen organism, and then growth conditions. So anyone else has any other questions? If not, then we can proceed to the final few pages.
Yes, we can proceed.
Yeah. Okay. Uh, is it visible?
Yeah.
Yeah. So as you can see, this is the bowl. This bowl is disinfected. The spoon and everything is flamed. As you can see, there's a Bunsen burner here. It is flamed. This jar contains mycelium, and this pot here at the back is the autoclave or your pressure cooker. It contains your sterilized material. So what you want to do is you want to spray this green bowl quickly, put it face down, open your spawn jar and open your substrate, put the substrate and spawn in this ball, use a spoon which is flamed, and mix it well so that you get a homogenized this thing. Next step is to basically so in this case, it's a very simple mold. We are trying to make a semicircle. So we fill the whole bowl up, and then we cover it with serine wrap, and then we let the fungi grow out. And the first growth phase is in the mold. So once you've mixed it, you need to put it in the dark place. It's not really required that it should be dark, although you could do it in the dark. Because we're talking about pleurotus here, so anywhere between 20 to 30 C is fine. The ideal temperature would be about 20, 25, 26, 27 C. But if you made this thing, lower temperature might be more suitable. So this is because at higher temperature there are more competing organisms which can thrive at higher temperatures. But pleurotus likes a range of temperature from as low as 16, 17 degrees to as high as 31, 32, 33 degrees. So if you're using pleurotus, try to, try to have the mold growing at lower temperatures, because that way the uh, competing organisms will not have ideal conditions to grow on, while pleurotus can continue to grow on that. But again, like I said, it'll take a little longer to grow because it's not very ideal. So 19, 18 degrees the lower limit for oysters growth, and 30, 33 degrees the upper bound. So the Goldilocks zone is somewhere in the middle. So see if you can achieve it. If you can achieve it, that's great. Then you should get your within 5, anywhere between 5 to 10 days, you should have your more growth ready. Try to keep the growth conditions as constant as possible. The more the fluctuation, the fungi gets shocks, and the shock can slow down its growth. So if it has constant conditions, it's better. So this growth will take anywhere between 5 to 14 days. What you do is you basically keep observing in between. You check for contaminations, any kind of green spot, yellow spot, brown spot, black spot. These are all signs of contamination. Keep a close eye on these. If there is a contamination, then what you can do is you can take this and take the substrate waste and compost it, and then begin again. Okay. So I mean, a lot of mycology is just patience. For anybody starting off, you will encounter a lot of contamination. But keep thinking why I'm getting this contamination, what could be the possible vectors for these contamination, and try and start lowering down each vector and cutting it off. So make sure, have a checklist that did I wash my hand? Did I cover my head? Did I cover my face? Did I, sterilize the equipments properly? Did I flame the equipments properly? Did I pasteurize the substrate properly? Was my grain spawn clean to begin with? So the more you experiment, the more you learn to identify what is right and what is off, and you can keep improving. But in the beginning you may encounter a lot of failures, and that's just fine. That's the whole process of learning. You fail a lot, and then finally you understand what to do, what not to do, and then you can also host one of these workshops maybe. As you can see in this picture, this is how it should look once it is colonized. You see how it's completely white now? It's completely white on the surface with slight metabolites present. This is when it's ready. At this point in time, we'll open the mold carefully. So this is a very important step, because at this point in time the material is fragile because it has a large amount of water. Like humans are 90 to 92%, 97% water, so are fungi. So a lot of water content, and that makes it very delicate. So please, when you demold it, please be very careful and do this process delicately. Again, you want to, before taking this material out, you want to disinfect everything, just to make sure that anything that the mycelium will make contact with is clean and disinfected. And now in this, after you've taken it down the mold, you can basically keep it in a closed space with some moisture. You can spray the wall of the container. That moisture is going to create a high humidity environment, which is ideal for the growth of the fungi. This will help the fungi grow in its final growth phase, and it will cover the mycelium, cover the substrate much more firmly, and the texture will become much more uniform. This could take anywhere between 2 days to 7 days, depending on the kind of conditions you have and depending on how well you can maintain these conditions. So, yeah, after this step is done, demolding is done. Then once you see that your mold is completely white, it's covered, the surface texture looks really nice. It's now time to deactivate the mycelium so that it does not continue to grow and maybe even fruit. You don't want it to fruit because then that will that'll change the whole shape, and then you'll have to cut the fruit and all that this thing. So you want to deactivate it. The ideal way to deactivate it is oven drying. You can dry it on inside an oven. Just leave the oven door slightly open so the hot air, the moisture can escape out of the oven, and about at 60 to 80 degrees for about 2 to 6 hours, and you should have a cracker dry material. Then you can use. If you don't have an oven, sun drying also works, but it takes longer. And if you are living in somewhere like Bangalore, Mumbai, where the humidity is really high, then it becomes really difficult to sun dry this material. So in that case, you can go for oven drying. And that's pretty much it. Congratulations, you've made your mushroom material in your desired shape. I encourage you to experiment with different kind of shapes. Try and make lampshades, bowls, really anything that you can imagine, and something that you can do easily at home. That's it from my side. Today's summary was, we spoke about different kind of mycomaterials. We spoke about the industry landscape, both globally and locally. We went step by step in the mycofabrication process, and we're going to have the final Q&A session before we wrap the session. So thank you very much. Thank you for joining today's class. I am humbled that so many of you gave me not only the platform to speak, but also your precious time. I hope you learned something today. I am accessible to your questions and queries. You can DM me, you can look me up on Facebook, find me, you can email me, you can message me. I may not reply to all your messages instantly. I try and get to everybody's this thing. It may take a day, 2 day, maybe even a week, but I try and answer everybody's questions. So that's it. I think this presentation will be made available on the MycoAsia website as well as their YouTube handle. So you can always rewatch it. If you have a doubt after this workshop, you can still ask me. So that's it. We'll begin the Q&A session and then close the
Yeah,
workshop.
Sheetal has a question first. She
Yes.
has raised her hand.
Yes. Hi, Sheetal. Sheetal, you're not audible. If I don't know if you're trying to say something, but I can't hear you.
Sheetal is not audible. Indu also has raised her hand.
Okay.
Maybe Indu will speak first.
Yeah, I have a
Yes.
couple of doubts. So my first doubt is basically to maintain the growth, I mean to say, after the sterilization process and after the inoculation, to maintain it as the temperatures and all, can we manage it with AC and all?
Yes, absolutely.
Even the
Absolutely.
Ganoderma, turkey tail and all also, can we
Yes,
manage
yes.
it?
For any fungi, they need the environmental condition, right? So if you want to use the AC to maintain those conditions, you can use AC, no problem.
Then what about the air exchange? Like for example, if we are doing it in a room and outside area is polluted, so we need an exhaust, right? So how to do with that exhaust? Can we manage it?
I mean, fungi are microscopic organism, and if you're growing 1 or 2 molds in a room, then there is enough oxygen for them for their entire lifetime. But say you're doing an industrial scale operation and you're filling the whole room up with growing molds, then they do need oxygen. And in that case, we use different methods like positively pressurizing a room to ensure circulation.
Okay. And one more thing is, I have tried this with Pleurotus once and using this straw, rice straw. So after the first phase of growth, after second phase of growth, the material was little fragile, even
Right.
after the second phase. How can
Right.
we overcome that problem?
So first of all, straw is not the best material for best growth substrate for Pleurotus. You may want to use some kind of sawdust and maybe wheat straw instead of rice straw. So that will give you a better CN ratio ideal for Pleurotus, and that should give you a better growth form.
So to get a strong mold, what would be the best species?
You can go for Fomes, you can go for Tramites, you can go for Ganoderma.
Okay.
Yeah.
And after second phase, can we put it in the incubator? I mean, to the spot for the second phase of
Yeah, you
growth.
can. You can
Continue.
put it in an incubator, and that will give better growth. Yes,
Okay, that's it. Thank you.
no problem. I think Sheetal commented something. I don't know how
Yeah,
to read
Sheetal
this.
posted her question. What is the
Yeah.
durability of these materials after drying?
Yeah, good question. So regarding durability, we've been working with a lot of brand partners, other partners, and we've been experimenting. We've been doing transit testing. We've been doing transport testing. So it's fairly sturdy. And this really depends on your biofabrication process, how well the material was fabricated. Like, you have different quality of steel, the same way you have different quality of biomaterial also. There's the cheaper quality, there's the more processed, which is more shelf stable, but slightly more expensive variety. So that way, the strength of the material really depends on the biofabrication process. But because it is being used in packaging in a lot of this thing, and we've done our own crash testing, with drop tests and transit tests. So it holds pretty well for most products.
Sridhar, please ask your question.
Hello, sir.
Yes.
You show the one slide in the scanning electronic microscopic observation, that myceliums.
Yes.
That myceliums have been you taken on the 5th day, on the 10th day, and 15th day. That is the have been you inoculated on the after is molded. That the substrate you will take and observe, or that fungal mycelium itself on the
Substrate. See, that's Sridhar, that's not really for you to observe, because see, anyways, most people can, even I don't have access to a electron microscope. Electron microscopes are only accessible to institutes and PhD candidates, and that too only certain PhD candidates. Certain equipments are not most. So that's not up to that. That slide was from a research paper that I can share. I should have probably referred the provided source for that. That's from a research paper that basically discusses the different morphology of different kind of mycelium. So, for Pleurotus, for Ganoderma, that's as the microscopy is purely to show you that like humans, you look different to me. I might be taller, thinner, or you might be bigger, bulkier. The same way in fungi, different species have different morphological properties of their hypha, their mycelial network. So that slide was purely to show you that your end product, the biofabricated material will very strongly depend on the quality of the fungal hypha. So there are several research papers available and accessible where you can go and read about the morphological properties of different fungi and mycelium. And basis that you can choose the fungi you want to use for your fabrication purpose.
Okay, sir. Thank you, sir.
Yeah.
Um, Before I go to Sabitra, I want to ask you Sheetal's second question.
Yes.
Can you share a little details about the testing? What are the parameters that needs to be checked for strength? So you, in your last answer, you talked about these
So
parameters. Yeah.
right. So there are standard tests for packaging material available. So you can go on, packaging. I think it's the Packaging Institute of India, their website. There are different parameters that you can test your material against. So, for instance, thermocol parameters are Young's modulus, stretchability, malleability. All these properties are there. You can either give your material to a material testing lab and they can do this for you, or you can for us researchers in the lab, we basically do very crude tests like drop testing from 6 feet, from 9 feet, 3 feet with our material. Then transit testing, which is basically we send our packaged goods from one end of the city to the other end of the city, and in the middle it goes through bumps and speed breakers, and then we check the integrity at the end station. So there are really two types of tests that you can do. Your crude test, which you can do at your home, drop your material, light up your material on fire. All these tests I've done. I've posted some on my Instagram, that you'll find these tests easily. And the other ones are the certification tests where your exact Young modulus, exact values, you can do it from any material testing lab really.
Sabitra, please answer your question. Please ask your question.
Hello, sir. So
Hi.
I would like to know I'm very fascinated with how you presented the flower pot, and now I'm thinking to do something like this, but I'm worried like how do you make it waterproof? Like, do you do any coating, or like once you dry the pot,
So,
like
So
the
mycelium itself is a hydrophobic material. So mycelium has water repellent properties on its own. So
so you mean to say once the
yes,
container or the pot is
once
dried, we don't have to worry about.
yes. Once the pot is dried, then there is very little probability of reabsorption of moisture, provided your material was fabricated well, which means that the mycelium is covered the surface and every contact point between the environment properly. If it has covered it properly, then there is very little chance of moisture reabsorption, and it remains hydrophobic. So you can use that material. In fact, both hydrophobic and inflammable. So if I try to light this up, it will be really difficult to light it up and fire. So yeah, if it's fabricated properly, then mycelium is hydrophobic in nature. It will naturally repel water.
Okay, thank you so much.
Yeah. Before we go to Dr. Shinoy, there is a question in the chat box by Dr. Kantaraja. And he is asking, does strength of initial fruiting body has anything to do with final fabricated product? For example,
Yes. So I've found some correlation between how strong. So you can see that this foamus is really strong. Like it's rock solid. Again, this artist strong. This is also really solid. Ganoderma appellatum. But then you look at Tramates, which also does a very good job of biofabrication, but is not as strong a fruiting body. But general rule of thumb is that if the fruiting body is hard, then its mycelium is also going to be hard. Of course, there's going to be exception, and there's no there's no set rule that you can. But yeah, general rule of thumb is if the fruiting body is hard, then it's a good candidate for biofabrication process.
Okay, Dr. Shenoy.
Thank you, Sharad. Can you hear me, Sharad?
Yes, yes, sir, absolutely clearly.
First of all, thank you very much for this wonderful, training program.
Thank you, sir.
Secondly, I would like to ask you a question like,
Yeah.
what do you see in terms of applications of mycomaterials in clinical setup, actually, in tissue culture
Right.
or inside the body? Yeah.
Right. So, sir, there are several applications for right now that I can think of. Is like, uh, you know, uh, uh, for instance, I very recently, I think you gave a reference to a fellow professor who contacted me. They were developing a biodegradable cadaver for medical research. And currently, most of these are made using polymers, plastic polymers, which resemble human flesh and skin. So biomaterials, both bacterial cellulose based and mycelium based, can be used to mimic skin like material, and these can be then used in cadavers or in surgical procedures where we can replace maybe plastic based bandages with dissolvable or materials which can heal the wound quickly, much quicker. But these are all possibility. There are researches going on. There's research on even laying down electronic boards and delivering tiny nanoparticles using mycelium in basically as drugs in your body. So all this research is going on, but the most marketable this thing is currently packaging and adjoining materials right now. But there is definitely a lot of research happening in using them in medical diagnostic and procedural usage.
Yeah, because recently I visited one of our CSIR labs, one of the
Yes.
oldest CSIR labs, Central Glass and Ceramic Research Center. They are preparing composites, using ceramic materials. So
Right.
they said they can also consider using mycomaterials for their
Yes.
research,
Yes,
Yeah.
another example of this is so for instance, we've been trying to grow lab grown meat. And the problem with the lab grown meat is that these cells need a scaffolding to grow on. When grown in media, they keep growing in one direction and you don't really get that meat, that muscular growth that you want from your meat substitute. So mycelium actually acts as a scaffolding for these mammalian cells to grow on. So then they have a scaffolding and they form a more meat-like texture. So there are several applications of mycomaterial that are being tried, and a lot of people are working on it, but we need way more people to start working on it.
Yeah, thank you, Sharad, and thank you, Gunjan. I'm done.
Yeah, there's one more question by Dr. Neelam.
Yeah.
Will the high temperature, such as oven with 80 degrees centigrade, have an effect on the mycelium compactness and ability to isolate?
Yes, good question. So like I said, mycelium is 90% water. So when you dehydrate it, there's going to be a shrinkage, and when you're doing this, you need to basically keep that shrinkage in mind and design your biofabrication process accordingly. So you need to keep a taper on your mold, just because if you're drying it in your mold, then it'll shrink and you need that taper and everything else. So that's something to keep in mind. The material will shrink. Usually, depending on how much moisture was there in the substrate to begin with, versus how much of it is left after the drying process, I've noticed shrinkage anywhere between 10% to 30%.
So I think are there any more questions? I have a question. The pot that you showed in your picture, is that also mycomaterial? The white pot with this snake plant?
Yes.
Amazing.
Yes. So we are also collaborating with a partner to make these flower pots and these seed, basically seed. So the wonderful thing about these pots is you can use these pots, and they're all, because they're uh, kind of a compost. Mushroom fungi, when they go through a substrate, they're essentially composting the substrate. It's called primary decomposition. So so not only is it a pot, but it's also a food source for the plant root system. So even if you don't add any compost to it, the plant roots eventually grow into the pot and start taking nutrient from the pots. And once the roots have branched out, you can take the whole thing and put it in the ground, and it will start growing it out of the
Right.
ground. So that's one of the advantages of using such pots. And we're working with a very big vendor for nursery right now to deliver a large number of these orders to them.
Yeah, so I have previously used pots that are made from cow dung, dried cow
Oh,
dung, and
yeah.
that is like you can grow your pot, a small plant in that, and just put it in the soil.
And just put it in the foil, and yeah, it's
Yeah, so it's
right.
similar concept. One more question from Pungipedia. How is that we can make a pot from a biodegradable material? Will it not break down over time?
Yes,
Uh,
it will. Yes, it will break down, and eventually you'll need to replant the plant in either a new pot or in the soil. But yeah, like all things biodegradable, it will break down because
Yeah.
eventually the roots will keep growing, and then because this is essentially soil for them, they'll keep growing through it and extracting nutrient and break down the material. So yeah. So it will break down, but
what if
these
we
are
put
not
some
these are
kind
not
of
permanent. Yeah, these are not permanent pots. So we've experimented with the pots, and the life cycle of these pots is about 7 months. So once you plant a plant in that pot, uh, in about 7 months, the plant grows enough that it starts consuming the pot, and then either you put it in a new pot and the whole process starts again, or you can just put it in soil and the plant will continue growing, but your pot will disappear. It will get composted eventually.
Yeah. What if we put some kind of coating which is very
Yes.
stable, resin, like
You
that?
do that. Yeah, you do that. The thing is that with even with some of our industry experience, is that our material is biodegradable, but it's the point is that we are so used to living in a plastic oriented world where everything is, shelf life of 18 months. That shelf life of 18 months is possible because of the plastic packaging. So now when you go to the market and you're saying, okay, I have this fantastic material, it's not like plastic, you throw it away and it'll biodegrade, and this is great for your sustainability initiatives and everything. Then then the question is, what about this stability? Will it be stable for 18 months? So then you do need to apply coatings and different types of this thing, and that's essentially a trade secret. Most people will not tell you what is the secret ingredient that they're using.
Of course.
Yeah.
Okay. Yeah, it was a great session, very informative. And are there any more questions?
Yeah, if there are any more questions, I think there are a few comments.
This is Manohar.
Yeah, hi.
I don't see any hands now.
You just mentioned about a duct
Manohar,
tape,
yeah.
right? You just mentioned about a duct tape instead of a filter. So what kind of a duct tape is it? Is it
No,
No,
you're not.
not a duct tape. Not a duct tape. It's a micropore tape. I'll just show you one second. Yeah, so it's this. This is this is essentially a micropore doctor tape. It's easily available, and it's essentially, you can see through it, right? It's like a filter. Can you see that it's
Yes.
transparent? It has micropore, so it's called a micropore tape. But the size of the pores in this is greater than 1 micron. So you need to apply several layers to sort of reduce that pore size. So I've found that 2 to 3 layers do a decent job in keeping out the contamination, but at the same time allowing the gas exchange to take place.
Can it be autoclaved?
Yes, it can be autoclaved.
Super cool. Thank you so much.
No problem. Any other questions? I
Okay.
think that's it. I think we've covered everything. If you have any more questions, feel free to post them to either Instagram or this thing. If you're on MycoAsia WhatsApp group, then I'm there. I can answer your questions there. Or else I've left all my contact information for you all to get in touch with me.
Sure. Thank you so much, Sharad, for your time and a lovely talk. We
Okay.
really learned a lot of things today.
I hope
Thank
I was
you.
of some use. It's been an honor to like speak to doctors and postdoctors and sort of be given this stage. Anyways, thank you. Thanks everybody
Thank you
for
so
joining.
much.
Hopefully we can
All
have
right.
more such workshops. Okay.
Thank you so
Bye.
much.
Take care, everybody.
Bye-bye.